Hello students, let us discuss particle nature of electromagnetic radiation, in which we are going to discuss Planck's quantum theory. As some of the experimental phenomena such as diffraction and interference can be explained by wave nature of electromagnetic radiation, but there are some observations which cannot be explained with the help of electromagnetic theory, just like nature of emission of radiation from the hot bodies, ejection of electron from the metal surface when the radiation strike it. So this is all can be explained with the help of particle nature of electromagnetic radiation. First concrete explanation for the phenomena of black body radiation was given by Max Planck in 1900. Let us discuss this phenomena in detail. When the solids are heated, they emit radiation over a wide range of wavelength. Do you have observed any sort of radiations emitted by the solids when it is heated? Look at this picture. What these are doing? Actually, they are carrying hot molten iron. And when you find it out, it is of reddish orangish color and which is actually glowing. So why it is glowing? Because it is emitting the radiation. So that means when a solid is heated, they emit radiation over a wide range of wavelength. For example, when iron is heated, it is first changes to dull red color. Then when it is further heated, it turns to dark red. Then it turns to white and it turns to blue in color. So that means when the iron is heated, it turns to change in the coloration, that is, it is emitting the radiation of wide range wavelength. As we know that the wavelength of dull red is different from dark red, is different from white and blue. So when we compare the wavelength from dull red to blue, it is observed that there is decrease in the wavelength, and as the wavelength and frequency have inverse relation, so we can say that there is increase in the frequency. That means on heating the iron, it is observed that there is decrease in the wavelength, as well as we can say that there is increase in the frequency. It means that a body on heating emits radiation. The ideal body which emits and absorbs all frequencies is called as black body. And the radiation emitted by such body is called as black body radiation. When we compare the intensity and wavelength of a radiation which is emitted by a black body, it is observed that at a given temperature, first intensity increases and then decreases with the wavelength after reaching to a maximum value. When you look at the picture, a curve which is given, that is intensity versus wavelength. In this, when you compare at temperature T3, it is observed that the curve reaches to a maximum value, maximum intensity, and then finally it decreases with the wavelength. So at the different temperature, when we observe that the intensity and wavelength are related in such a way that the intensity increases and then decreases with the wavelength. So it shows that intensity versus frequency curve of a radiation from a black body depends only on its temperature. So, as the temperature T3 is greater than T2 than T1, so we can say that we are getting the three different plot as shown in the figure. So the above experimental results cannot be explained satisfactory on the basis of wave theory of light. So the Planck suggested that atoms and molecules could emit or absorb energy in a discrete quantities, not in a continuous manner. This theory was given by Max Planck, which is popularly called as Planck's quantum theory. What is according to this theory? That whatever the energy is absorbed or emitted by a body is not taking place continuously, but it is in the form of small packets of energy. These packets are called as quanta. So, particularly in the case of light, the quantum of energy is called as photon. So, what is clear from this theory? That according to Max Planck, the energy emitted or absorbed by a body is not taking place continuously. It is actually in the form of small packets, or we can call it as in the form of wave packets. These are named as quanta. Particularly in the case of light, we call it as in the word photon. So the Planck's quantum theory is the most important theory which is given by Max Planck. According to him, the amount of energy associated with the quantum of radiation is directly proportional to the frequency of the radiation. That means each quantum have a particular amount of energy. That energy is directly proportional to the frequency of the radiation emitted by the body, and that is equal to E is equal to h nu. Here nu is the frequency, h is a constant of proportionality called as Planck's constant, and its value is given 6.626 into 10 raised to power minus 334 joule second. So it is one of the important value which you need to remember, that is Planck's quantum theory. It gives value of h, that is Planck's constant, that is equal to 6.626 into 10 raised to power minus 34 joule second. So in this video, we discussed about black body radiation, and we discussed a new theory which is given by Max Planck, that is Planck's quantum theory. According to this theory, the energy is not liberated continuously, but in the form of packets of energy, which is called as quantum, and the energy of this packet is given by a formula E is equal to h nu. In the next video, we'll be discussing the further details. Thank you everyone.